Hello, I'm Mark from Weaver Auto Parts. At Weaver Auto Parts Machine Shop, we can handle small machining jobs up to the very large. Our people's knowledge is second to none with over 30 years combined experience. Our work environment is clean, well lit, and climate controlled. We are in a constant mode of equipment upgrade. The attributes of new equipment we are looking for are cleaner operation, more accurate to improve quality, faster completion to keep our prices fair. We at Weaver Auto Parts value our customers and take pride in our work. Thank you for taking the Weaver Auto Parts Machine Shop tour today. The first phase of our machine shop tour involves accepting work. A customer can come directly into our Sauk City machine shop and drop work off. We have the capability with the crane system to unload the heaviest work or take the smallest job in. Our machine shop foreman is here to help the customer. Machine shop work can also be dropped off at any one of the 17 Weaver Auto Parts stores. And our daily truck service between locations will get it to our machine shop the very same day. The second phase of the machine shop tour involves disassembly and inspection. Disassembling and inspection is done on all parts as the first phase, and visual inspection is performed to look for obvious problems such as leaking head gaskets, indicating a warped head, oil color which might indicate water contamination, or any other problem that is obvious to the person doing the disassembly. Station 3 involves cleaning. At this point there are various cleaning methods. We have the products taken apart, so for cast iron cleaning we have an oven cleaning system that bakes blocks and heads and crankshafts or any cast iron item at 400 degrees for approximately 20 minutes, baking all gaskets, grease, and foreign materials from the cast iron. The oven system has an afterburner and allows no pollutants into the air. After baking the casting, it is put in a second machine called a steel shot machine. The steel shot blasts the casting and blasts it to the point where the casting looks like a new raw casting. After 20 minutes in the shot machine, the cage in its work is put into a tumbler where the work is tumbled, which allows all shot material to fall to the bottom of the machine. At the same time, the work is cooled by fans. Along with oven cleaning and shot cleaning, smaller parts and aluminum can be cleaned in our sonic cleaner, which cleans these parts by the method of hot water, a biodegradable chemical, and sound waves that blast the surface of the parts being cleaned. Section 4 involves cylinder head inspection. At this point, the cylinder heads are inspected and checked for cracks by the use of a magnetic particle inspection or pressure testing. Magnetic particle inspection consists of sprinkling a colored magnetic powder throughout the casting and magnetizing the casting to check for trails that would indicate a crack. Aluminum heads cannot be tested with magnetic particle inspection. Aluminum heads or cast iron heads and blocks suspected of having an internal leak are placed on a pressure tester and pressurized to 40 pounds. We then spray the casting with a soap water solution to determine if there is an internal or external leak. In the event a cast iron head has a crack, we are capable of repairing some cracks with an iron-tight plug method. Some aluminum heads are repairable by use of an aluminum heliarc method. Station 5 involves cylinder head, guide, and seat machining. The casting is mounted on the cradle of one of our two guide and seat machines. The purpose of this machine is to replace guides and to cut seats or replace them. The cutting of a seat assures a perfect finish and angle. Years ago, seats were ground with a stone, but due to stone wear, it created a non-perfect angle and non-consistent finishes. Another huge advantage of cutting seats is the air cleanliness. All valves are then placed in our glass bead machine. The glass bead machine is an enclosed cabinet that operates like a sandblaster, but it is able to contain the dust and recycle the blast media, which in this case is glass beads. The glass bead, when sprayed at high pressure at the head of the valves quickly removes all carbon. The valves, after blasting, are then taken to our valve refinish area. The first process is to place the valves into our valve stem polisher machine, where the valve stems are polished till a like-new condition. After the stems are polished, we place the valves into our valve refacer. This machine has a 3-ball air chuck which holds the stem perfectly straight and rotates the work. The angle of the valve grind is set to the OE specs at this time. The valve face is ground also. After the valve face is ground, it is removed and placed in a new chuck where the valve stem is refaced. At this time, the reground valves are washed in a parts washer, blown dry, and given a final inspection. The valves are now ready for installation into the cylinder head. To ensure a complete and professional cylinder head recondition, most heads will need to be resurfaced back to manufacturer's original equipment specifications. A general rule is when the head has a warpage of 0.003 to 0.004 or greater, it must be resurfaced. For newer engines with MLS, multi-layered stainless steel head gaskets, the tolerance is less. The process involves mounting and leveling the head on our resurfacing equipment. The bed of the machine traverses while the dry diamond cutter head rotates to complete the resurfacing on the face of the head. The end result is a perfect finish that, when properly torqued, will assure a proper head gasket seal. The cylinder head is now placed in a finished wash jet wash machine. The head is placed on a cradle, rotated, and spray nozzles spray hot biodegradable wash to give the casting its final cleaning to remove any dust that may remain. The cylinder head, valves, and remaining clean parts are taken into the assembly room. The assembly room is a separate, sealed clean room. In the assembly room, all cleaned work is set for final assembly. All parts are checked and then assembled to complete the job. Clearances are checked at this time. For final completion, the heads are packaged, tagged, and placed into the plastic storage bag. Work is now ready for final billing, pickup, or delivery. Dirty and clogged fuel injectors are one of the prime causes of misfires in modern engines today. When an injector is dirty or clogged, it can cause one of two severe problems. The number one problem from a dirty injector will cause an insufficient or irregular spray pattern. When there is a poor spray pattern, the engine does not burn all the fuel and fires incorrectly, causing rough running and loss of power. When an injector is clogged, it will typically cause a drip from the injector, allowing raw fuel to run into the engine. The raw fuel dilutes the oil, causing premature engine wear or total misfire. It is recommended to have your injectors tested anytime you remove the heads for valve work. Engines with misfires typically have a bad injector as the cause of the problem. Weaver Auto Parts also sells new and remanufactured injectors for gas and diesel engines. Flywheels for small and large cars, along with heavy-duty and industrial flywheels, are resurfaced on our 10 horsepower Van Norman flywheel grinder. The rotation of the table with the opposite rotation of the motor assures an excellent machined finish. Flywheels are assured accurate after removal from this machine. We can do flat or recessed flywheels from the smallest to the largest. This process is a must when replacing any clutch to ensure the new clutch mates to a refinished flat surface. The align boring station is a process whereby the engine block or cylinder head is aligned bored to create a perfectly straight bore for the crankshaft and block or the camshaft in the head to rotate within. The process is done by mounting the engine block or cylinder head within a cradle. Material is then removed from the main bearing caps to close up the diameter of the crankshaft saddles. After this is completed and main bearing caps are retorqued to the block, the align boring process begins. The align boring process involves a perfectly straight bar with cutting bits that recut the saddles back to the OE specs within 1/1000ths. For blocks requiring camshaft boring, the bore housings are cut to allow for an oversized bearing to fit. This process is a must for any engine that has spun a bearing or the bearing saddles have become non-concentric. Engine balancing can be done on the smallest, inexpensive engine up to the largest, most expensive diesels. Balancing an engine assures smooth operation. This process is done by the removal and addition of weight to the parts being worked on. When we balance an engine, we balance the crankshaft with the harmonic balancer installed on the front and the flywheel on the rear. The crankshaft is spun and metal is added or removed from the various parts of the assembly to ensure total balance. The Winona Van Norman balancer gives a machinist an electronic readout to ensure total accuracy. The bob weights are installed on the crankshaft to simulate the weight of the pistons, rings, rods, and rod bearings. Pistons, rings, rods, and rod bearings are all weighed for perfect conformity. These parts are weighed down to 2 grams for a stock engine and within a half gram for race engines. Our new Sonnen RMC 1550 will accomplish cylinder boring, sleeving, and resurfacing. This machine is capable of reboring a cylinder or reboring to facilitate a repair replacement sleeve from a small gas engine to the large diesels. The second function of this machine accomplishes the resurfacing of the engine deck. The mounting fixture allows us to do 60-degree V6s, 90-degree V8s, or straight 3, 4, 6, or 8 cylinders. The carbide cutters and speed-controlled traverse allows us to provide whatever RA finish manufacturer's spec. This machine with its high technology computer allows the most accurate cutting and measuring within 1/1000th of an inch. We are capable of handling 2-cycle boring, 4-cycle small engine boring, along with the largest of diesels with bore sizes varying from 2.5 inch to 6 inch. When a block is removed from the cylinder boring machine, it then goes to a honing machine. Cylinder honing and finishing is done on our Sonnen SV10 honing machine. This new machine is computer controlled. The way in which this works is a block is mounted to a fixture in the machine. The cylinder bores are then measured with a dial bore gauge. Once the size is determined, the diamond-headed hone is inserted within the bore and the size and stroke is set within the automated machine. The bore is then honed to specifications. Specifications during this process can be reviewed on the computer panel. Unlike stones, the diamond head does not wear as it hones the cylinder. The diamond head assures us of a perfect and accurate finish that meets original equipment specs. During the cylinder honing, the computer displays the actual bore image so as the machine operator can make necessary adjustments. Oil consumption occurs in engines when there is a poor finish or inaccurate size in the cylinder. By utilizing the diamond head and computer readout, it assures us of a perfect finish, which is known as crosshatch. This allows for proper piston ring to cylinder wear to match manufacturer's spec. Oil consumption and emissions are non-existent with proper cylinder sizing and finish. After the crankshaft is cleaned, as discussed in the cylinder head section, the crankshaft is placed on a straightening device with the V-blocks and slowly rotated to determine the straightness of the shaft. If the shaft is found to be more than 1/1000th out, the shaft must be straightened prior to grinding. Straightening the shaft is accomplished by leaving it on the V-blocks, clamping it down, and having a hydraulic ram bend it back into specs. Once the shaft is straight, and if the customer orders the work, the shaft is placed within the Quickway Magnafluxer. The shaft is placed in the center of a large, powerful, round magnet. The shaft is covered with oil containing fluorescent filings. The tent is pulled over the work to bring darkness, and a black light is shined upon the work. If the shaft is cracked, the fluorescent filings beneath the black light will show a definitive line. By doing this process, it ensures that a crankshaft is not installed on the verge of failure into your engine. All diesel engine shafts require Magnafluxing. Gas engine shafts remain an option to the customer. Magnafluxing is a low-cost way to ensure your engine from failure. Crankshaft grinding is a method to resurface and polish the main bearing journals and connecting rod journals to facilitate an undersized bearing. As an engine accumulates miles, the connecting rod and main bearing journals begin to wear. At some point, if enough miles are accumulated, or oil starvation occurs, or contaminated oil with particles or fuel cause the bearing clearances to become too large, the engine will knock or seize. At this point, the shaft is placed within 2 chucks of the Winona Van Norman crankshaft grinder. This machine is one solid, extremely large casting and allows for 0 vibration. The stroke of the shaft is then set within the chucks. The grinding stone is then changed to facilitate the journal size of the shaft. The journal is then ground to correct size and radius. All journals are ground. We never grind less than a complete shaft. This brings crankshafts back to like-new condition. Oil passages are then chamfered. The shaft journals are then polished to a mirror finish. Bearings are ordered to facilitate the size of the shaft. As an example, if 10 thousandths of material was removed from the shaft, we purchase a 10 thousandths undersized bearings. Bearings are commonly available in sizes like 10 thousandths under through 40 thousandths under to accommodate how the shaft was ground. This assures the engine of smooth running and proper oil clearances. Once the shaft is off the grinder, we do a finished wash, including brushing all oil passages, tag it, and bag it in our clean assembly room. Connecting rods rotate with each revolution of the crankshaft. The lower end of the connecting rod will become elongated over time, and the upper end with the bushing style will do the same. Connecting rods need reconditioning after oil contamination, starvation, or a long period of use. The process for lower end reconditioning begins with removal of metal from the connecting rod and connecting rod cap. This process reduces the overall dimension of the rod. The connecting rod is then brought back to the original size by enlarging the bore on the sun and honing machine. The upper end is reconditioned by removing the bushing, installing a new bushing, and honing the bushing back to the original specifications. Once both ends of the connecting rods are completed, the connecting rod is then checked for straightness on the Sunnin connecting rod straightener. Once the connecting rod has been determined to be straight, it is ready for final cleaning. The connecting rod is placed in the finished jet wash for its final cleaning prior to boxing and bagging. Connecting rod integrity is extremely important to a smooth operation of any engine. Many times a manifold, due to the great number of times it is heated and cooled, becomes warped. This machine allows us to place the manifold on the flat surface and grind it back to a flat and smooth surface so as to allow for easy installation and no exhaust leaks. Brake drums and rotors will need resurfacing virtually every time brake pads or shoes are replaced. Today's brake pads and shoes are extremely hard and wear the brake rotors and drums after so many stops. Many times rotors or drums will become warped due to the high temperatures that they operate at. Weaver Auto Parts can take care of brake drum and rotor grinding at most all Weaver Auto Parts stores. Weaver Auto Parts will not grind rotors or drums beyond manufacturer specs and has a large selection of new rotors and drums for your convenience. Weaver Auto Parts has a Goodyear hydraulic hose crimping system for hydraulic hose from 1/4 inch to 1 1/4 inch. We have a large selection of fittings needed to make up hydraulic hose for your auto, truck, ag, and industrial needs. Radiators, heater cores, and oil coolers work in a harsh environment and are victims of vibration and clogging. When a unit is brought into our shop, we first soak it in our cleaning tank containing a hot solution. After the unit is cleaned, we place it in our enclosed flush booth, connect it to an air and water backflush, and clean the internal area with a flushing method. The outside is then pressure washed in the same booth. Flow of the unit is then checked if requested by customer. If the flow is determined to be bad, we recommend tank removal and rotting of the core. If the flow is acceptable, the unit is then placed in our hoist and pressure checked within our test tank. Any leaks found will then be repaired. More common today are aluminum cores with plastic tanks. Aluminum is more difficult to repair than the older style of brass and copper. Many times aluminum radiators are replaced rather than repaired. Weaver Auto Parts has a huge inventory of new aluminum radiators on hand at all times. In some cases, aluminum radiators with a plastic tank can be repaired by replacing a single tank and gasket. We are a locally owned and operated Wisconsin business celebrating 40 years of service. With good communication, we'll do our best to take care of your needs. We thank you for taking the Weaver Auto Parts Machine Shop tour today.